43 summation as n goes from 3 to infinity, 1 over n times ln n times ln of n. Lots of natural logs here. Okay, so for those of you that like to follow algorithms, one of the algorithms that I tell my students to think about is, which kind of follow is, if there's like obvious u substitution, then it might be a good idea to try the integral test. This, we can do a substitution actually. Let's look at the integral version first. So I apologize if you liked this variable in terms of x, I used n because I just copy and pasted, all right? But you can use any variable. It doesn't really matter, at least for me. If your teacher's picky, then follow what your teacher requires. If it's an x, if it's a y, if it's a theta, I don't know. Just follow whatever variable convention your teacher requires. Otherwise, you can use any variable. Okay. We can let u be natural log of natural log n. Because if we use the chain rule, du is 1 over the argument, and then times the derivative argument, which is 1 over n. Okay, so this is our 1 over u, and this over here, n ln n, and this dn is our du. So it becomes 1 over u du. After we do the substitution, it cleans up really nice, and then we have to change the limits of integration as well, okay? And if we evaluate this, it's infinite. So if we go by the integral test, the series diverges. But we have to also, at least bare minimum, state the conditions for the integral test. Let's go back up here. It needs to be positive and decreasing. And continuous, some teachers require that. Okay, so it's all three from 3 to infinity. So at the bare minimum, state it, but even better if you can show some work to show it, all right? So again, if you like algorithms, here's the algorithm. I see a substitution, u substitution that can be done. So let's try the integral test.